Dear students, in this video we are discussing about some problems which will be related to confidence interval. The first question is like this. A random sample of 500 pineapples was taken from a large consignment and 65 out of them were found to be bad. Show that the standard error of proportion of the bad ones in the sample of this size is 0.015 and deduce that the percentage of bad pineapples in the consignment almost certainly lies between 8.5 and 17.5. Also obtain 95% confidence interval for population proportion T. Construct 95% confidence interval for T if no estimate of P is available. This is a question which is based upon confidence interval for proportion. In the question it is clearly mentioned that 500 pineapples was taken. A random sample of 500 pineapples was taken and out of that 65 were found to be bad. 65 were found to be bad. So the question is related to proportion, confidence interval on proportion. Now the first part of the question is show that the standard error of the proportion of the bad ones in the sample of this size is 0.015, and the second part is the confidence deduce that the percentage of bad pineapple should lie in the between 8.5 and 17.5. The third part is 95% confidence interval for P, and fourth part is 95% confidence interval for P if no estimate of P is available. So we are having four parts in the question based on the given data. First of all, we have to identify what all are the given data, and we have to solve this sub questions one by one. So as per the question, we are having a random sample of size 500. So n is equal to 500. Out of 500, 65 are found to be bad. So proportion of bad one is P is equal to 65 by 500. So this is same as 0.13. So Q can be identified as 1 minus P, that is 0.87. Standard error of P can be identified as square root of PQ by N. So 0.013 into 0.87 by 500, its square root. So it will be 0.015. So standard error of P, we obtained it as 0.015. So the first part of the question is proved. The standard error of the proportion of bad pineapples in a sample of 500 size is 0.015. Now we have to deduce the percentage of bad pineapples in the consignment, which almost lies between the interval 8.5 and 17.5. We have to show that the percentage of bad pineapples should be in the interval 8.5 and 17.5. For that, what we have to do is the given data is a confidence interval whose minimum limit is 8.5 and maximum limit is 17.5. We have to convert these things into the corresponding probability value, and it is giving that the percentage of bad pineapples. So we have to represent it as 8.5 percentage and 17.5 percentage. So for that, we know that the confidence interval for proportion is mod P plus or minus Z alpha by 2 into square root of PQ by N. So what we have to do is we have to split up the equation. P minus Z alpha by 2 into square root of PQ by N is 8.5 percentage. Likewise, the upper limit P plus Z alpha by 2 into square root of PQ by N is 17.5 percentage. Now we make this percentage in terms of decimals. So it will become P minus Z alpha by 2 into square root of PQ by N is equal to 8.5 by 100, and after substituting the P and Q values, it will become 0.13 minus Z alpha by 2 into the standard error value, that is 0.015 is equal to 0.085. This is same as 0.085. We mark it as equation number 1. In the second case, p plus z alpha by 2 into square root of pq by n is equal to 17.5 by 100. So after substituting the p and q values, 0.13 plus z alpha by 2 into 0.015 is equal to 0.175. So we obtain two equation 1 and 2, and in 1 and 2 we are having the common term 0.13. So we have to solve these two equations in order to identify the value of z alpha by 2. So I am doing 2 minus 1, equation 2 minus 1. So the calculation is like this. 0.13 can be cancelled by doing 2 minus 1. Then the remaining is z alpha by 2 into 0.03. We have to add these two terms. So it will become 0.03 is equal to 0.09. So z alpha by 2 is equal to 0.09 divided by 0.03, which is equal to 3. Z alpha by 2 equal to 3 is a valid value for z. As per our standard normal table, z can take values from minus 3.9 to plus 3.9. Z equal to 3 is a valid value. Z alpha by 2 is equal to 3 is a valid value in the standard normal table. Therefore, we can say that the percentage of bad pineapples can lie between 8.5 and 17.5. If we obtain a value which is greater than 3.9, then we can say that this is not possible. അതായത് നമുക്ക് സ്റ്റാൻഡേർഡ് നോർമൽ ടേബിളിൽ മാക്സിമം ലെഫ്റ്റ് സൈഡിലേക്കും റൈറ്റ് സൈഡിലേക്കും പോകാവുന്നത് -3.9 മുതൽ +3.9 വരെയാണ്. അപ്പോൾ അതിനിടയിൽ ഏത് ഇസഡ് വാല്യൂ കിട്ടിയാലും അത് പോസിബിൾ ആയിട്ടുള്ളൊരു വാല്യൂ ആയിരിക്കും. 3.9ന് -3.9നേക്കാൾ ചെറുതോ അല്ലെങ്കിൽ +3.9നേക്കാൾ വലുതോ ആയിട്ടുള്ളൊരു ഇസഡ് വാല്യൂ ആണ് കിട്ടുന്നതെങ്കിൽ നമ്മളുടെ ഈ ഇൻ്റർവെല്ലിൽ പോസിബിൾ അല്ല എന്ന് നമുക്ക് കൺക്ലൂഡ് ചെയ്യാം. ഇവിടുത്തെ കേസിൽ 3 ആണ് വന്നേക്കുന്നത്. സോ ഈ ഇൻ്റർവെല്ലിൽ പോസിബിൾ ആണ്. The third part of the question is to obtain 95% confidence interval on P. For that we are having the equation like this: small p plus or minus z alpha by 2 into square root of pq by n. Substituting the value of p as 0.13 and square root of pq by n, the standard error is 0.015, and for z alpha by 2 it is 1.96. After the calculation we obtain the result like this. So we have to do like this. Now we move on to the last part. To construct 95% confidence interval would be if no estimate is given. If no estimate is given, what we are going to do is we have to assume P and Q should be equal to 0.5. So 100 into 1 minus alpha percentage is equal to 95%. Alpha is equal to 0.05. Alpha by 2 is equal to 0.025, and we already know that for 95% confidence interval, Z alpha by 2 is equal to 1.96. If no estimate of population parameter P is available, in such a situation P equal to 0.5, Q equal to 0.5 for standard error. Based on that, we have to calculate the confidence interval for P, and it is given by small p plus or minus Z alpha by 2 into square root of PQ by n. Substituting the value of square root of PQ by n, that is 0.5 into 0.5 divided by 500. After obtaining the result, we have to take the square root. It should be equal to 0.0223. So we have to substitute all these values in the confidence interval calculation. 0.13 plus or minus 1.96 into 0.0223, and we obtain the final result as 0.0862 less than or equal to P less than or equal to 0.1738. So this is a corresponding confidence interval. So this is all about this question. Next question. This question is based upon large sample confidence interval for me. Just look at the question. A sample of 100 gave a mean of 7.4 kilogram and a standard deviation of 1.2 kilogram. Find 95% confidence limit for the population mean. So in the first line, it is given that the sample size is 100 and the sample is having a mean of 7.4 kilogram and standard deviation of 1.2 kilogram. So we can write it as n is equal to 100, x bar is equal to 7.4 and s is equal to 1.2, and we have to obtain 95% confidence interval. So as per our calculation, we know that 100 into 1 minus alpha percentage is equal to 95 percentage, and we already by heart the value that Z alpha by 2 is equal to 1.96. Now as it is a sample size is 100 and we are having only the sample data, we have to use a separate equation. For larger sample, we already studied the equation like this. For a larger sample, the confidence interval on population mean can be identified as x bar plus or minus Z alpha by 2 into S by square root of n. Instead of population variance, we are using the sample variance. By substituting the values in the equation, we obtain the corresponding confidence interval as 7.1648 less than or equal to mu less than or equal to 7.6352. Hope you understood these problems. Thank you.